Okay, hi everyone. So, what we're going to do in this tutorial is we're going to add a very small amount of robotic actuation to our projection mapping setup. So this is sort of like an optional extra, depending on how much complexity you want to build into your final project. But I thought this is a cool additional step that some of you might want to explore. We're going to build this very simple TouchDesigner network here, and if you can hear this noise in the background, what's actually going on, if I show you what's sitting in front of me, is I'm driving this little servo motor here from TouchDesigner. So if I zoom that out a little bit, you can see that at the moment I've just got a LFO that is going between 0 and 1, and we're sending that same rotation with a little bit of mapping via USB serial straight to the Arduino. So we're going to go through just how to download and set up your Arduino with your motor, and then how to make this little network and add this into your overall projection mapping setup. Okay, let's get started. So the first thing you're going to want to do is go to this website here, which is download and install the Arduino IDE, which is our little programming environment that we use to tell the Arduino, what hardware it's using, what signal it's looking for, and what to do, how to send the signal to the hardware or receive a signal, all that type of stuff. So, get your Windows version or your Mac version. And then if I open up my Arduino IDE here, the first thing I'll just ignore those updates for a second. The first thing you're going to want to do is we will just check that we're looking at the right device. So here, I've already set mine to my Arduino Uno, but we can just select the device here. I can type in Uno, make sure I'm looking at that Uno, and I want to be looking for it on the USB serial communication port, and hit OK. The next thing is we're just going to test that everything is working properly. So we can actually load a whole bunch of example scripts. And first of all, we're going to load this one called Blink. So if I click that, it will load this little piece of code here. I can close the servo rotate one I had. I'll give that code to you a bit later. And again, just make sure I'm connected to my Arduino Uno. Whoops, looking for it on the USB, that's good. And this is really what this is going to do. It's just going to check everything is plugged in and working. So anything here with a backslash and a star is commented out. It tells us what it's going to do. It's going to turn on the LED light on the Arduino for 1 second, then turn it off for 1 second. And we can see here that's what it's doing. The things that are not grayed out are the things that are functional. In our setup, it's initializing that we're going to use the built-in LED. And then in the loop, we are writing high and low, which is on and off, and a delay, which will be 1,000 milliseconds, I guess, 1 second. Okay, so we can just tick verify, and that just checks there's no errors in the code. And then we can hit upload. And if your Arduino is plugged into your computer, then it will upload. What you should see is something like this. You can see that the little LED light is blinking, and that's exactly the code that we uploaded. So that's good. Okay, the next thing you're going to want to do is we will just unplug the Arduino from our computer to make sure that there's no power going to it, and then I want you to wire up your motor. Now I've made a small wiring diagram for you. Okay, so this is the wiring guide for wiring up your Arduino. Basically, we've got this little micro servo motor, SG90, which is perfectly powerful enough for our needs here, and it'll have 3 cables coming from it. Now, this motor has its own little controller in it. With other types of motors, we might need to have some external sort of motor driver, but these servos have their own driver inside. We've got 3 cables. One will be giving us power, which is red. One will be grounding us, which is usually brown. and then one will be receiving the digital signal here, which is yellow. And then you're going to have the square, usually square profile USB programmable USB cable that'll be going to your laptop. And that's both, in this case, it'll give us enough power to run this motor, but it will also give us the signal from our TouchDesigner straight to our motor. So what that means, what's cool about this is that we can simultaneously do our projection mapping, but at the same time, we can synchronize our projection mapping to our motorized movement because we're driving it all from TouchDesigner. So just as a side note, you don't need TouchDesigner to run the Arduino and the motor. You can just put the program for the motor straight on the Arduino. And actually, that's what we're going to test first. The cool thing about this pipeline I'm showing you here is that we can send the same signal from TouchDesigner to our motor while sending our projection mapping. And what I'm hoping is that means you can do some cool, like, synchronized effects with projection mapping and this motorized movement. Okay, so once you've got your motor wired up, I'm actually just going to pop back into the Arduino IDE, and we're going to load in a different sketch, which will just test that our motor works. So here, if we go to examples and we go down to Servo, we'll load this one called Sweep. And I can close that last one. Okay, it looks like I'm still connected to my Arduino Uno. That's good. And now here, we've got the author here. And basically it will, first we'll set up the fact that we're using a servo motor, gives it a name, tells it to start at position 0. It attaches it to port 9. So this is important. As I show in the wiring diagram, I want you also to attach your servo to port number 9. You could plug it into any of these, but you just have to make sure that the code is looking in the same place. So if you plugged your Arduino into port 10, this code would have to have a 10 here, right? So that the signal is going to the place where the motor is actually attached. And then again, we've got a loop which says we're moving between position 0 and position 180 with a delay of 15 milliseconds to allow it to reach the position. Let's just verify this, check everything looks good, and then we're going to upload it to the Arduino, and your motor should just start moving. Okay, something didn't work there. I'm just going to close this, and I'm just going to check all my communication is correct. I'm just going to quickly unplug and plug my Arduino back in, and then reload the Arduino IDE, and something was wrong with our communication. It wasn't sending or uploading correctly. So I'm just going to check that once again. I'm just going to load the example sketch of servo to sweep. Close this other window. Check that we are looking at the Arduino Uno. Yep, that looks good. Okay. Now I will just upload this. Okay, so that's worked. It could have just been that, I don't know, maybe it was still looking for the previous instance of the Arduino IDE I had plugged in. But if I just take a quick video on my phone, you'll see that we've got this sweep function here now running. And that's running exactly the way that it's programmed on the screen. Okay, so that means that all of our wiring is correct. So now we can proceed to TouchDesigner. So I want you to leave the wiring as it is, but we're going to upload a new sketch, which I will give you, and then we're going to build our TouchDesigner network. Okay, so the next thing I want you to do is you can just make a new sketch, file new, and you'll get a blank sketch here. And then you can just copy and paste. I'll put this in the description. This is the code we need to connect to TouchDesigner. It's something I developed once with a friend, and then I fine-tuned it a little bit just with ChatGPT. Basically, we are setting up a serial communication between the servo motor and a signal being sent from TouchDesigner via the Arduino. And we're just looking for integer values between 1 and 180, and a small delay to smooth the motion. So you can just copy and paste this into your Arduino IDE. You can save it. I called mine TouchDesigner Servo Rotate and GPT just to remind myself which one it was. And then once again, just make sure you're connected and pointing at the right device. I have unplugged mine because the noise of the sweep was annoying me. Let me just plug that back in. There's my sweep. And now I'm just going to verify this to check the code looks good, and I'll upload it. And then my sweep has stopped, thankfully. Okay, so that's all uploaded just fine. So now I will close the Arduino IDE, and let's get into TouchDesigner. Okay, so here we are back in our projection mapping scene. This is basically where I left it last time. You know, I've got the Cantan mapper here and all of our layers going to our nulls here. Now we're just going to add a small new section that will send the serial communication signal to our Arduino and then to our motor. So I'm going to double click with my left mouse, and I'm just going to add a signal that will be an LFO, which I think we've spoken about already, a low frequency oscillator. I'm just going to change a couple of parameters on that. I'm going to slow it down a bit, put the frequency down to 1.5, and I'm going to change it to a ramp. So now it's just going from 0 to 1 and then back to 0. Then I'm going to add a math, double clicking with the left mouse. I'm just typing math, and I'll connect these up. And then I'm just going to math that in its range to 90. And then I'm also in the operation panel here, I'm going to round it off to an integer value. So here you can see we're starting with a floating point value. We've got decimal points, and we're going to an integer. And that's just because that's what our servo motor is looking for. It's looking for whole numbers, not decimal point numbers. Okay, then I'm just going to put that out to a null, and we can call that like Arduino send, something like that, makes sense. Then we just have to add a couple of DATs. So we spoke about DATs, I mentioned them in one of the TouchDesigner tutorials, so that's what we're going to use here. We need a chop execute, just click that here, and then we need a serial, and that will automatically give us this little serial callbacks. First of all, we need to tell our chop execute which chop it's looking for. So I'll just type in Arduino _send, which is what I called the previous one. So now we can see that data connection flowing back from Arduino send to here. And then we just need to change a little bit of the code in how this is being executed here. I'll put this in the description as well. It's only a few lines that we have to change. And just be mindful that you can't make spelling mistakes here. That will you'll get an error message. It'll tell you what the mistake is, but we just got to be careful with how we type things in. Okay, so I'm just going to just delete that return, and I'm going to type in rotation _value equals integer brackets val. And if I put in a little comment here, that's just saying, you know, convert the value to an integer. Now we've already done this in the math, but to be honest, if I didn't do it in the math and I do it here, it doesn't really work. The motion's too jumpy, so I just have it in both places, and it seems to work. I'm sure there's a better solution here, but if I make sure it's an interval, like double checking here, and on the math, it seems to work better. Okay, so then we just print open brackets f, open some quotation marks, and we're going to, I'll just move my mouse, we're going to be sending, got to type properly, sending value colon curly brackets rotation _value, and then close the curly brackets, close our quotation, and close our regular brackets. And then what this is doing is it's print the value to the text port for debugging, just in case we need it. Then, okay, serial underscore dat equals op, open and close brackets, open some quotations, serial 1, and then new line, hit enter, serial underscore dat dot send, open close brackets, f, double quotation marks, curly brackets, rotation underscore value / n. Now just check I haven't made any mistakes here. Hopefully that's all right. And what this is doing, it's going to send the value to the serial dat, and then return, which should end our function. Okay, I'm just going to close this. And okay, I haven't made any mistakes. If I did, I'll just deliberately make a mistake here. If I just put another T there or something, we'll get this cross. And that cross is just telling us we've made a mistake. And here it's because I've misspelled this variable rotation value. So now it doesn't know what it is. And if I click that, it'll say, should say somewhere, rotation value is not defined. Did you mean rotation value? Yes, that's exactly what I meant. So let's just correct that. Okay, so that should work now. The last thing we've got to do is, if you see we've got an exclamation mark here, it's saying it could not find the device. We just need to tell it where to find it. So if we go to the port on the serial DAT, and I just select USB, hey, all right. So I'll just get out my phone camera again. You can hear it on the computer microphone, but now we're running. And if you look at, if I can focus my phone with one hand, if you look at the Arduino send, oh, it looks like I almost pulled my plug out for a second there. Yeah, it looks like I did. Hold on, let me just plug everything back in. Sorry, I'm just holding a camera and a delicately wired thing at the same time. So here we've got our Arduino running, and it's following the number that we're creating with that LFO. And you can experiment with different ways of creating numbers. I might make another tutorial showing you. The only thing I've noticed is depending on the speed of the numbers, things sometimes get a little bit jumpy. And talking to one of our other colleagues here, Samuel, he was saying that I think we sort of have to hit a sweet spot between like the speed of the data that the robot, that this little motor is looking for, and the speed of the data that we're sending from TouchDesigner. So I don't know that stuff sort of as well as Samuel, but trial and error, there are some signals I've found that are very, very clean, like this LFO, but we can play around with that a little bit in class and always get some more detailed information if we need it. Okay, so that's it for this tutorial. Now we've got this little connection here that is sending information to our little motor, and then of course we can use this same LFO signal to do something in our animation, so therefore we can have synchronization, which I think is really cool, and I look forward to seeing what you make with this. Okay, bye-bye.